human side of technology. I'm going to talk today about what it's like to actually design and build an application to run in the cloud as part of a startup. So our team has been running these lessons, we call them the AWS Cloud Kata, for startups and developers. We use this as an opportunity to teach best practices for architecting and implementing for the cloud. It's a fairly complex presentation. I'm going to do my best to explain it to you. And my hope is that I will get through all the content. If time runs out before the slides run out, then we'll definitely make the slides available to you. Let's talk about being the idea person or the tech person for a startup. At some point, you are thinking, maybe you're watching your friends, you're watching industry trends. You have a great idea for the next competitor to Angry Birds, let's say. You decide you're going to make the Happy Chicken instead as your app. So let's go through the process of how do you decide what to build, how do you decide what is essential, what is optional, how do you break that down into different features, different services? Let's talk about the actual implementation, how you then map that into what you build, what you use from existing services, what do you use from the cloud, what do you use from various open source packages. One of the models that we've seen within our team that's very successful is the cloud gives you the ability as a startup to make a lot of tests, a lot of experiments, a lot of trials, with the expectation that not everything is going to succeed. You're going to have some failures. But because of the cloud, sometimes you're going to build an app, you're going to put it online, and you're simply not going to get very much attention or traffic or users for it. But because you haven't made investments in your own infrastructure, the cloud model lets you fail fast, fail cheap, but then fail forward. So what do I mean by fail forward? The idea of failing forward simply says, because you have not spent a lot of money on an experiment that didn't work, you still have money, you still have resources for the next time around. So you can continue to experiment, test, try and try again until you succeed. So fail fast, fail cheap, but fail forward. At a certain point, you're going to build that app, you're going to start testing it, you're going to start seeing it's finally working. You're getting some more users, the users are staying active, the word is spreading about your app, all the graphs are going up and to the right, you're seeing that you're getting more and more users for your app. At that point, you are starting to be a success, and you can start to think about how do you go about scaling that success. This is when the power of the cloud really starts to come into play for you. One of the important things, you want to, at the early stages, you want to have that wonderful idea for something new. You need to test or validate it. You want to be able to do that inexpensively and quickly. You want to see, is this something that the market really needs? We all know that we can have our own wonderful ideas for something new. And to us, personally, it kind of seems like the best idea ever in the history of the world. We tell it to our friends, and they say, I don't know, it doesn't sound so wonderful or amazing to me. So you do need to validate your ideas before potential customers in order to get a better sense of how they'll work. There's this concept that's relatively new called the lean startup. The idea of the lean startup is you want to build your first version of your product quickly and inexpensively, and with a very small feature set. The name for this, they call this the minimum viable product, or MVP. That picture there is actually the first computer mouse that was ever built from the 1970s, I believe. You can see it looks really simple. It looks rather crude, but it was enough to prove you can move something with your hand and have a push button on there to activate as well. So that was the minimum viable product for the first Macs. Some of the important concept of the MVP, you want to release quickly. You'd like to get that first version out there in front of the public so that they can look at it, try it out. If it's interesting, you'd like to get some feedback from them quickly. If it's not what they need, you'd like to also get that feedback quickly before you've made a long investment and invested a lot of development time as well. That first minimum viable product, you're going to have a very limited set of core features. So as the product designer, it's going to be up to you. Look at that very, very long list of things that you are thinking about implementing, and then carefully choose only the essential, only the most important product features to implement the first time through. You're going to save most of those features for further iterations. So part of this lean model, release early, learn, iterate, keep going, but iterate in production. Perhaps you're going to be launching new improved versions of your app every day or every week or perhaps every month. One of the really important aspects of this, you need to, as your app is going into production, you need to have various ways to measure the success. You might need to know how many downloads do we have, how many active users. Maybe you need to put some special statistics and metrics in your application to measure what parts of the application are being used, what features are being used. Are users staying active and busy with the application over the long term? Or are they just simply trying it out for a day or two and then abandoning it? So it's very important when you think about building your app, and when I say app, I'm meaning everything from something like a website to an actual app running on a mobile device or a tablet. You need to figure out what kinds of data, what kind of metrics you're able to translate from the app back to the server. You want to be able to store those, collect those, analyze them, and take them from that raw data to some level of actual business understanding. It's very important to think about that part up front in your design process. Perhaps your first app is little more than a splash screen and a few essential features, and then the metrics reporting to tell you, are people actually starting to make any use of this little app? Let's start to think about application architecture. How do we actually go from our idea to the product? This is the way to not build your product. This is kind of the architecture of the past. The single gigantic application, everything tightly coupled into a single application, a monolithic monster that you simply have trouble taking apart. All the pieces depend tightly on each other, tightly connected, tightly coupled together. You want to think about taking that one app and saying, how can we subdivide it? How can we break it down into some smaller parts, some smaller components? You do that for a couple of reasons. Some of those parts might not turn out to be essential for your first release. You also might find out that some of those parts you might not need to implement yourself. You can find various pieces of open source software, commercial software, or even cloud services that could actually implement parts of that app for you. So it's very essential to go from that one big monolithic monster into a decomposition, where you're thinking very hard about the architecture of your application, and you're thinking, what are the essential pieces? At that point, you now have a set of building blocks. And you're going to start to think about actually labeling those building blocks with what are the pieces that I need to have. Features, what kinds of identity, how do I store data? Am I storing data on the device? Am I storing data in the cloud? Do I need relational storage? Do I need key-value NoSQL storage? Do I need some back-end compute services? Do I need a content distribution network? All these things. So as you're starting to think in depth about the architecture of your application, you're going to start taking it apart. and getting a very deep understanding of the different components that you have available and that you're going to need to build. Now, as developers, I know that we sometimes take pride in being able to build all the different parts of an application ourselves. There's certainly a technical pride and skill of being able to build every different component. However, it's actually very, very important to realize that many of the components that you might need are already available to you, and that instead of building everything yourself, you're going to make use of open source code, cloud services, commercial software, take existing modules where possible, and use those as part of your application. So after you have figured out what set of services and features you need, you're going to start saying, what are the things that I can uniquely do myself? The things that actually differentiate my app from other apps. Those are the pieces you'd like to implement, and ideally, all the other services are effectively not differentiated from your competition. So you might as well use other services in order to implement those, because you're not going to be able to do a better job on those than any other app builder is able to do. So you want to think in terms of effectively outsourcing the undifferentiated parts of your app to various kinds of services. Amazon services, open source services, and so forth. Now I'd like to go into a little bit more detail on the products that I speak of, the Amazon Web Services, or AWS. The first really important concept of AWS is it's a global service. We have an organizational model we call regions. There are currently 9 separate public regions located in different parts of the world. And when you decide to store data or process data, you always do so with respect to a particular region. So you would choose to store data in, let's say, a region in the United States, a region in South America, a region in Europe, a region, one of our 4 regions in Asia Pacific, or in Australia. So that decision is made specifically by you based on where your users are located and any particular constraints you might have on locations where you might legally be able to store or not store data and to do processing. So we will never copy data from location to location. That's always, it's going to stay in whatever location you provide. So you pick a particular region, and then when you're building your application, you choose a particular set of availability zones inside that region. So you can think of an availability zone as similar to a data center. Each of our regions has anywhere between 2 and 5 separate availability zones, or AZs. And the availability zones are constructed with independent physical buildings, power, cooling, network security, and so forth, so that any kind of a failure that might affect one availability zone in a region is just not going to affect the others in the same region. This means by running your app in 2 separate availability zones in a region, you can build an application that's tolerant to system failures, and then it becomes very highly available. We also have a set of edge locations for content distribution and for DNS lookups. We currently have 52 separate edge locations in strategic locations around the world. Building up from the regions and the availability zones, we have a wide variety of different services. Time is short, so I won't go into great detail on any of these services. Suffice to say, we have compute services, storage services, networking, databases, analytics, and content delivery at the foundation level. It's very important to know with respect to all these services that you can effectively pick and choose the set that you would like to use in your application. Most applications are not going to use the full menu of services. They're going to use a little bit of storage, a little bit of processing, perhaps a little bit of database, but it's the rare application that's going to need this full collection of services. Building up from the foundation services, we have services for email, for device push notifications, message queuing, video transcoding, search, workflow, and application streaming. We then have high-level deployment and management services, log monitoring of system statistics, deploying and managing your application, and then dealing with identity, dealing with user accounts. Really important to know that all these different services that are part of AWS, they're all available to you on a pay-as-you-go basis. So you should be paying for the cloud services that you consume. And then as developers, you probably like to know, these are all accessible to you by application programming interfaces or APIs. So every different function that you can do within the cloud, from launching instances, to loading servers, to creating databases, to storing information from databases, everything at the fundamental level is all API powered. Layered above the APIs, we also give you software development kits, we give you command line tools, we give you visual tools, we give you tools to plug into Eclipse and Visual Studio as well. But at the base, everything inside the cloud is API powered. We have libraries and SDKs for a wide variety of different programming environments, Android, iOS, .NET, PHP, Python, Java, JavaScript, Node.js, and Ruby. So whatever your favorite language is, the chance is that we already have an SDK available for you. Let's talk a little bit about the process of finding some more software components. A couple of places you might think about looking. We have an online store for AWS called the AWS Marketplace. So commercial software vendors can list and sell their applications within the AWS Marketplace. So if you need, for example, advanced log management or advanced security or virus scanning or special kinds of developer tools, you can search the AWS Marketplace. You can find various applications available to you. You can see the per hour and the annual pricing. And you can simply buy and then start using these applications within the marketplace and use these as perhaps components for the projects that you're building. You can also, of course, use open source tools and open source libraries and open source code can be run on the cloud. So you might spend some time going to GitHub and looking there for packages that are helpful to you. Also, some of our best AWS customers have built their own tools and have released those as open source. For example, Netflix is a very well-known and very good AWS customer. They actually have what they call the OSS, the Netflix OSS, or Open Source Software Center. And in there, you can find a wide variety of tools that will be very helpful to you as your cloud usage expands. Things like various monitoring tools, security tools, tools to verify the amount of fault tolerance that's built into your application. So my message to you then is you have access to a lot of different locations where you might be able to find various components to use in your application. Now let's talk a bit about when you start to implement the services your application needs. Remember that we took that one big monolithic box and we broke it up into a number of different services. So what you might want to do, and this is something that we've done very, very successfully for the Amazon.com retail shopping site, behind the implementation of the website are thousands of different internal web services, each of which has a very specialized task, each of which is implemented by an individual team, and each function exposed and accessible only by an API. So you might think about building particular services of your application as particular features as individual services, each also available through an API. When you build things as services, you define the API first, you define that programming interface. That gives you the power to simply publish that API. Maybe it's published only within your own development team. But that means that you can, if need be, you can re-implement the feature inside of that service without having to get all of your any other changes to happen to your application, because the other code is written in terms of that API that you publish. You'll generally think about long-term stable APIs, but stable APIs give you the ability to rewrite, to reindent, to tune, to optimize whatever it is that you're building. When services need to talk to each other, we find that when we think about many applications built with large numbers of services, You want to be able to scale. You want to be able to run multiple copies of the service on different processors, on different instances. So you think about scale out. You also want to think about reliability. What happens if one of these services gets momentarily overloaded? What if it gets stuck? What if it stops responding? We find that the best way to make a highly available, very resilient, very strong kind of a service connection model is to use message queues to transmit requests from service to service. And we have a service itself called the Simple Queue Service, or SQS, that is the message queue model that lets you connect from service to service. So with the message queue between two services, the message queue has the ability to, if the receiving service is getting overloaded, it's not a problem because messages will simply accumulate in the queue service. You can accumulate tens, hundreds, even thousands of messages if your receiving service is slow or not operational. The important thing about the message queue, it allows both sides of the transaction to actually run independently at their own speed. So this blue service can be posting messages either fast or slowly to the message queue. The orange service can then be pulling messages from the message queue, examining them, decoding them, processing, sending the messages on to the next location, and at its own rate. So the message queue gives you resilience, it gives you some fault tolerance, it gives you the ability to adapt to changes in your operating environment. Another very useful technique is to use something called a circuit breaker. The idea of the circuit breaker is that connections from service to service, you want the service to have some awareness if it might be overloaded, and if the service becomes overloaded, for it to actually bypass. And so that when the service finds itself overloaded, you can switch basically to a failover mode. And instead of failing the entire system, that one little service can momentarily fail and then return default values or simpler values rather than breaking down the entire system all at once. Now, because you've built your system as a big collection of services, that means that you have the ability to scale very easily. You can run different services on different machine instances. You can load balance inbound and outbound traffic across these different services. They become easy to monitor. You can get high availability by running multiple copies of the service on different instances. But the idea is you want to do all of this scaling, load balancing, and monitoring at the level of individual services. This gives you a lot of flexibility as your system grows more complicated and as it scales up. You also want to think about how are we going to separate the state of our application. Let's see the ideal model. You're going to keep the state separated from your data. You're going to use scalable services to actually monitor, to store your state and your data. We have services such as Amazon S3 for storing unstructured data, DynamoDB for very high performance key value storage, and then Elasticache for transient in-memory key value storage. If you're using these high-performance services to store your state, that means that if you're running your workers on your services, the services can take a message, process the message, read data to and from these scalable storage services as needed, and then send the message along to the next processing location as needed. If any worker has a problem, the state is safely stored in the services rather than as part of the message. So let me tell you just a little bit about one of our services. This is a really important service for building scalable apps, especially scalable mobile apps. This one is called DynamoDB. It's a very highly scalable NoSQL data store. When you create your tables with DynamoDB, you do something called provisioning. And with provisioning, you actually tell DynamoDB how much performance you need. So you tell it how many reads per second and how many writes per second you need to be able to do to each individual database table. You might start out really small. Maybe you need to do, let's say, 10 writes per second and 20 reads per second. At the point when you provision that table with DynamoDB, it's going to take your read and your write requirements. It's going to spread your data out across a number of solid-state storage devices. in order to be able to give you that level of reading and writing that you request. You start running your app, it's doing some reads, it's doing some writes. As you get closer and closer to that level of performance that you configured in, when you get to, let's say, 80 or 90%, you can configure DynamoDB to send you an alert that says, I'm now getting to the limits of how much reading and writing I have provisioned. You can then go to our management console, and you can turn the dial up. You can provision additional reads, additional writes, spread that data out across additional servers. With this provision model, you can start out very small, 5, 10 reads, writes per second, but you can scale up into tens, hundreds, thousands, hundreds of thousands of reads or writes per second with no administration, no downtime, and no need for a system administrator to do any work for you. You simply go to the console, enter your new values, your previous throughput, DynamoDB will automatically rescale for you. The data is stored redundantly, so every item is actually stored separately on 3 separate servers, and all stored on solid-state disks with very high performance. So any read or write to DynamoDB is going to complete within 10 milliseconds. So this is a perfect ingredient for building very highly scalable applications. So you've probably heard this term SOA, or service-oriented architecture, in the past. So we've tried to actually kind of modernize SOA, and we call it Cloud SOA, or Cloud SOA. So basically, this is a service-oriented architecture that's going to take advantage of some cloud principles. And the things that you gain from this kind of more modern approach to SOA, you're going to get apps that are always on. They're going to be self-healing, so that if instances die, you can use services like auto-scaling services and load balancing services to detect failed instances, replace them with fresh instances. And they're not fragile. They're able to perform effectively when under heavy load and if components are misbehaving in some way. So some of the principles, we're going to now talk about some of the principles that we use inside of Amazon for our own development. When we're building new services inside of Amazon, or almost anything new, we create a small team. And there's a name for this inside Amazon. We actually call it a 2-pizza team. The idea here is you want to keep that team small enough that you can actually keep them well fed by just 2 pizzas per meal. You don't want to have a very big team because they're very difficult to organize and difficult to manage. But that team has full responsibility for building, running, scaling, monitoring a particular service. Within Amazon, our model is that the team that builds something is also responsible for running the service. So that there's no handover from development over to production, development over to ops. One team has responsibility for building and running. This increases reliability. It means that you can't have one team blame the other for failures, and increases trust in the overall system as well. Because we structure our own work as a large collection of independent services, this means that teams can build their own work and proceed at their own pace. In other words, our teams are decoupled from each other, and there are a very small number of internal dependencies that go across different teams. This is one of the secrets, an open secret, about how we're able to innovate so quickly. Let's take a look at how we're going to actually put this all together into a solution, kind of reversing the model that we had before. What are some of the things we have to think about? One of the things that we find essential is automation. I talked a little bit about our collection of services, and everything in all those services I talked about is fully programmable. You can absolutely access any of the functionality through APIs. So the idea is, if you can program something, then you should automate it. So creating databases, filling in tables, launching server instances, establishing network connections, message queues, all those kinds of things. Yes, we give you facilities to do that by hand, but we strongly prefer that the optimal way to do this for best results is you want to automate everything. Tools, scripts, templates, recipes that are going to automatically set up your entire system infrastructure for you. Just a quick look at all the different SDKs that we offer, as I listed before. Pretty much every popular programming language is represented by an AWS SDK. Here's a very simple code sample. So this is uses our EC2, our Elastic Compute Cloud. The idea of this simple sample here, it shows you how to actually launch a server by simply making a function call. When you launch that server, a couple of really important parameters. What machine image to run. So this is effectively your base operating system you're launching. An SSH key pair, so you can log into that instance. The type of instance, is it small, medium, large? We have a wide variety of different instance types with different amounts of compute power and memory and disk storage. And then two other important values. What is the minimum number and maximum number of servers that you'd like to launch with this one call? So this one Java call that you can make could launch 1, 10, maybe even hundreds of servers if your count limit is set high enough to allow you to launch hundreds of servers at a time. So instead of going to the console and manually launching servers, you'd probably figure out some way to launch them automatically in code. You can also do the same equivalent from the command line if you'd like, where you could put these commands into a shell script. Let's talk a little bit about this concept of a machine image. So we call this an AMI, or an Amazon Machine Image. An AMI is simply the cloud equivalent of the root disk of your computer. It's got your operating system, it's got your tools, your applications, your code on there. And we give you a large collection of pre-built AMIs, and we also give you a set of tools that let you to build and customize AMIs on your own. You think of this AMI as a starting point and as effectively the known good state for a part of your application. Now, there's a lot of subtleties in the ways you might choose to build AMIs. You might choose to build them totally statically, where you start with, let's say, an Ubuntu AMI, and then you go in and manually install a number of packages and you save out that configuration. Or you might have some kind of a script that runs that is going to automate some of that process. Or you might use some kind of an automation tool, maybe using something like Chef or Puppet or Ansible to, at launch time to the AMI, actually finish the configuration and customization process for it. Basically, along these three steps, you can trade off speed of launch, because the less work you do at startup time, the more quickly your instance is going to launch, versus control and flexibility. So you have a number of different choices that you can go here. So any of the popular third-party configuration management tools can be used to set up your stack on your individual instances when you launch them. We also give you a set of AWS services for managing the lifecycle of your application. Services like the Elastic Beanstalk, which automates all the resource management. So you simply hand your code, you give Elastic Beanstalk one file with your Java, your Python, your Ruby, your .NET code, or your Docker script in there. Elastic Beanstalk will then create the instances, the load balancer, the auto scaling, launch the database, set up all the monitoring, set up all the failover, take care of all those important details for you. Or OpsWorks is a DevOps framework to make it really easy to find your application as a series of language. A third really important service at the lifecycle management layer is called CloudFormation. The idea of CloudFormation, you can build some templates, and the templates are effectively a declarative specification of your resources. So within the template, you can specify all the different application components, your message queues, your databases, your data warehouses, your instances, your load balancers, your networking configuration. You can specify all that in a text file. You can put that text file under version control, and you can then launch multiple copies of this infrastructure through the CloudFormation system. And then finally, at the lowest level, you can launch all these services by yourself, kind of on a do-it-yourself or a DIY model as well. The CloudFormation template, as I described, actually lists all of the different services and their connections and their configuration. And you can either build the templates manually, you can launch all the services first, and you can then capture that configuration in a template, or there are third parties that actually have template building and management tools as well. So by launching the template, you can specify complete architectures like that, all within a single text file, and launch the entire thing effectively as a single transaction. If you're doing dev and test on the cloud, you might want to think about using different aspects of the cloud for project management, continuous integration servers, source code repositories, build servers, and so forth. A number of our customers are using the cloud as their dev and test home. Kind of another illustration of how you use cloud information templates. You might actually have build servers that build environments based on templates, and then launch them, test them, run a set of test cases against them. You can see here we've got multiple versions of the build environment, version 1, 1.1, 1.2. You can build each of those and easily regression test them with full automation. So think in terms of both application versions of your code and then infrastructure versions of your AWS infrastructure, both of which you can automate and control. You can deliver continuously. You can kind of think in kind of an agile model for getting things started, continuous integration, and then at the point when you're fully deployed, you can go to a complete DevOps model where all the parts are included and managed within the cloud. Just about running out of time. Going global in a couple of minutes. This is like a really powerful advantage of the cloud. I talked to you before about the fact that we have multiple regions all over the world. So you might choose to launch your application in a single region. And then you start to say, well, what if people in the United States would find this interesting and useful? You can easily use the same templates, use the same infrastructure model, launch your application in any of the AWS regions within a couple of minutes. We also give you services for doing things like A/B testing, where you can compare two versions of an app, see which one is better at attracting and retaining users over time. The A/B testing model, very straightforward to launch in the cloud because you can create your infrastructure so easily and so dynamically. You can then measure and log everything with our CloudWatch service. You can get all the metrics. You can pull those up from the console, and you can see exactly how things are performing. Once you start doing this, the idea with the cloud model, you're going to be able to keep on iterating across this entire life cycle quickly, easily, and cost effectively. Keep innovating, and away you go. And there we have it, exactly 40 minutes. Thank you so much.
我也听得到，非常谢谢 Jeff 的讲答，有问题吗 ？Any question？ 对。
Do AWS plan to implement the Go language SDK?
That's a really interesting question. Are we doing the Go language with SDK? I don't often know a lot about our future plans, but I would actually, I don't see why we wouldn't do it. It's if we see developers asking for it, we do our work really based on customer requests. I think you're the second person to ask me for that this month, so I will certainly be happy to go back to the team and see if that's something that they're thinking about doing.
我们应该还可以再有一个问题 ，last question， 另外。